So before the next session, we want to thank our sponsor, Prowler, who is also part of making this great conference happen. So be sure to go and talk to them in the breaks. Next up on stage, we have Kurtis and Paul Schwarzenberger, who I'm going to introduce now. So Kurtis works as a lead technical architect at the National Archives, where he's leading the work on cybersecurity and cloud architecture in AWS. Paul is a cloud security architect and has worked across many different industries, and has also, amongst other things, created the OWASP domain project. He is a frequent speaker at many cloud security conferences and also spoke at the first Forward CloudSec, as some of you may remember. Give a big hand.
Hi, everyone. For the avoidance of doubt, I'm Kurtis Mash, Lead Technical Architect at the National Archives UK.
And I'm Paul Schwarzenberger, a Cloud Security Engineer. So to start with, how many of you in the audience have implemented or started to implement AWS Backup? Okay, that's impressive. And how many are planning or thinking of doing so over the next year, especially after you heard Kat's talk this morning? Not many more. Okay. Right. Well, at the National Archives, we are the official archivist and publisher for the UK government. We host physical records ranging from the Domesday book to the Magna Carta, and most recently the coronation roll of King Charles. We're open to the public, so anybody can walk in and request to see a record. As well as our physical records, we also host digital records. So these digital records range from records that are transferred from different government departments in the UK to parliamentary records, to public inquiries, and the digital assets from other public bodies. It's very important for us to safeguard our digital assets on behalf of the country. And so we're particularly concerned about the risk of ransomware attacks. Now, as you, I'm sure, all know, ransomware attacks have become more and more prevalent over recent years. So just a couple of examples from in the UK. A couple of years ago, the British Library suffered a ransomware attack that took out their operations for several months. Earlier this year, we had Marks & Spencer, and a ransomware attack took off their online sales and a lot of their in-store systems for, again, a period of months. According to ransomware.live, who keep track of this, they report, as of yesterday, 288 disparate attacker groups, ransomware attacker groups, and 5,360 victims so far this year. And that's probably an underestimate because many organizations don't report ransomware events. But suffice to say that I would personally say all of the organizations in this that we all work for are potential victims of ransomware. And this is an area we all need to be concerned about. So, you'll see in the photo that this is a photo of our archives. We take very good care of our physical assets. And we need to be equally diligent at looking after our digital records as well. One of the best defenses to protect against ransomware attacks is backups. So, Kurtis, what are the National Archives' requirements for a backup solution of our digital archives?
So, as we thought about what we needed to do, we came up with 4 key criteria to get our backups working. Firstly, we wanted our backups to be immutable. We wanted to trust that in a recovery scenario, the data we recover hasn't been tampered with and can be trusted. But it also extended to making sure our backups couldn't be deleted, not by a malicious user, not by an admin or developer within one of our workloads, but also not by some of our more privileged users. Think your AWS organization administrator. We wanted our backups to be centralized. We did this for 2 reasons. We follow AWS best practice and put each of our workloads in a separate AWS account. But if we just put our backups there as well, and that account were compromised, we risk that account being closed or suspended, delaying our recovery until after we've got our account back via AWS support. We also have many teams at the National Archives. If we asked each team to make a backup solution and deliver it, we'd have a lot of different ways to back up and a lot of different ways to recover. In a recovery scenario, we wouldn't have time to consider the multiple ways to recover. We wanted a cookie-cutter approach we could deploy to every service we have in AWS. We had to consider data protection. You may think you're an archive. Your data is public anyway, but that's simply not true. We do hold data that isn't yet open to the public and data on our users. By putting all our backups in one place, we're creating the ultimate honeypot, and so we need to make sure our backups were just as secure as the source systems they came out of. And finally, we wanted a managed service. We want to spend our time doing things that we're good at, archiving and preserving digital records, not operating a backup solution.
So, Kurtis, was the way forward just to turn on AWS Backup?
So this was a quote from me very early on during the project. Many of our services are in AWS, and they're using AWS native technologies. So the logical next step was to just turn on AWS Backup. Unfortunately, it wasn't quite that simple. For those who are unfamiliar with AWS Backup, there are 3 key resource types: backup vaults, backup plans, and backup policies. Think of a backup vault like an S3 bucket. With a small amount of configuration, a name, and a KMS encryption key, this becomes a container for your backups to be stored in. Backup plans are the configuration of AWS Backup itself: what to back up, when to back it up, and which vault to put it in. And then backup policies are an AWS organization version of a backup plan. You set them in your management account, like you would a service control policy, and it deploys backup plans into your workload accounts. This is where we hit our first problem. AWS Organizations was fantastic at deploying backup plans into our accounts, but each of those plans expected an IAM role and a backup vault to already exist. There was no native way within AWS Backup to deploy these as well.
So you mentioned that backups are encrypted with KMS keys. So there are quite a few different types of KMS keys. I find this a bit confusing. Would you mind explaining that to us, please?
So for those who haven't banged their head on KMS recently, there are 3 types of key. AWS managed keys are the default for most services, and we've all used them at some point. These keys exist within your account, but you can't change the key policy, nor can you delete them. Those who have used AWS will know that an AWS managed key can also not be used for cross-account actions, like sharing data or copying data. For this, you need a customer managed key. These keys are managed by us, the customer. We create them, we set the policy, and we delete them. It is possible to lock yourself out of a custom managed key through the key policy. But when you do this, there's a tried and tested method with AWS support to check you've done it and restore access on request. These 2 types of keys are supported for backup vaults within AWS Backup. There's a 3rd type of key, AWS owned. These are newer and slowly phasing out AWS managed. Like an AWS managed key, they can't be deleted and you can't change the key policy. But unlike an AWS managed key, they do work for cross-account sharing, and they exist in an AWS-owned AWS account rather than our own AWS account. When we came to thinking about what we wanted from our immutability, half the problem was already solved for us. AWS Backup stores backups as objects, meaning that once the backup is taken, it is immutable. The data cannot be tampered with, leading us to consider, how can we stop our backups from being deleted? And there are a few methods we could try for that. Firstly, if you know S3, you know object lock. In AWS Backup, there is something similar, vault lock. Vault lock comes in 2 modes, governance and compliance. In governance mode, the backups cannot be deleted unless you're a user with specific permission to remove the lock. In compliance mode, much like in S3, the backup cannot be deleted until the vault lock has expired, not by us and not by AWS. So you may be thinking, why don't we just put all our backups in compliance mode and call it done? And that's what we thought too, until we realized we're now centralizing our backups. We're copying them across account, therefore we have to use customer managed KMS keys. When we do that, those keys can be deleted. There's no lock for a KMS key. Within 7 days, one of those keys can be removed. We'll still hold a backup, but the data in that backup is effectively inaccessible. We'll never be able to get it back. If we want to protect from this, we need to swap our backups to using AWS managed keys, copying them first cross-account, and then again into another vault managed with an AWS managed key. AWS have actually identified this as a problem themselves, and recently released logically air-gapped vaults. These vaults enforce compliance mode and the use of a AWS-owned key. How not all resource types support this type of vault.
So, Kurtis, how does AWS Backup work across different AWS services?
AWS Backup is great as it provides a single API across many services to manage backups. It does this by acting as a shim over the existing AWS APIs. Taking RDS as an example, it already has a backup feature through snapshotting. AWS Backup just orchestrates that on our behalf. Some services, like S3, didn't have a native backup solution, and so the AWS teams have worked together to make AWS Backup the native functionality for that. This is great, but it's led to a complex matrix of feature support based on the resource you're trying to back up and the region you're currently working in.
So does a centralized AWS backup solution work for all AWS services?
Unfortunately not. There are some services that aren't yet supported by AWS Backup, and then there are some things that are limited by the underlying API. Looking at the RDS example, one thing we ran into was using RDS multi-AZ database clusters, a best practice from AWS. Unfortunately, these can be snapshotted, but the snapshots can't be copied, meaning we're stuck with the backup living in the same account again, an issue we have to accept or engineer around elsewhere.
And how much does AWS Backup actually cost?
That's difficult to answer. AWS Backup charges differently depending on the vault you use, the service you're backing up, and the amount of data you're retaining. The best advice we can give is to consider your backup plans carefully and regularly review them. Make sure that your backup plans align to your recovery objectives. Also consider data volume. AWS Backup does a really good job of deduplicating from the start, using incremental backups where possible. But there are ways you can configure it to undermine this effort. Finally, think about your API costs. Most services this won't matter, but when backing up services like S3, a bucket with 1 million objects is suddenly 1 million GET object requests, and that's before you realize half those objects are in Glacier and need retrieving too. AWS have published loads of guidance on how to manage AWS Backup and watch out for cost savings. We recommend you read all the documentation before starting your implementation.
So what is the design of the central AWS backup solution at the National Archives?
So very early on, we decided we wanted our centralized solution to be centralized, and that also meant a single deployment. So we created a backup delegate account within our organization, both to hold the backups and to manage the deployment. We deployed to this using Terraform, and then use CloudFormation stack sets to deploy into our workload accounts. We're using stack sets to protect our Terraform from our ever-changing state of our AWS organization. Within our workload accounts, we deploy an IAM role and a backup vault and a few other resources. We then use AWS organizations through backup policies to deploy our backup plans. For each resource type, we back up first to a vault local in the account, and then copy to a vault in our central store. This is either going to be a logically air-gap vault directly for the resources that support that, or for the resources that don't support logically air-gap vaults, we copy first to an intermediate vault, re-encrypting with the customer-managed key to allow that cross-account access to happen. Then we listen to Event Bridge and copy once again into our standard immutable vault, which is encrypted with an AWS managed key for us to use.
So that might have sounded quite complicated to you. It sounded quite complicated to me. But the good news is that we have made it simple for any of you that do want to follow in our footsteps. So we decided to open source the GitHub repository that deploys this centralized infrastructure, and you'll see the QR codes here. So let me actually sort of show you some of this here. So this is the actual GitHub open source repository. It's National Archives, Terraform AWS Immutable AWS Backup. Now, you might be wondering, isn't that a bit of a weird name for a repository? But that's because we decided to make this a Terraform module, and that's the naming convention that you need for a Terraform module. So the reason that we chose this approach of using a Terraform module, so for those of, so who here implements or uses Terraform? So it's, yeah, quite widely spread. Yeah, quite a good response. So for those of you that do particularly, you'll know that using Terraform modules is a very effective and straightforward way of deploying infrastructure because all of this infrastructure that Kurtis described, you can basically, all you need is sort of 6 or 7 lines of code. And not only that, but as and when we release new versions of the module, it's very straightforward to update. You just update the module version. So, and it will fit in with your existing CI/CD processes and Terraform repository structure. As well as the repository and the public Terraform registry, we have also published GitHub pages for documentation. The link is, well, I provided you before, but is also, there's obviously a link to that from the repo. And this is the actual documentation. So as you'd expect, we've got diagrams, details of how to deploy, and the different options that you can configure for your own custom requirements. We also have some information on prerequisites that you need to put in place before installing this module. These mainly relate to settings that are needed at the organization level, such as delegating to the backup account and enabling various features and policies across the organization. OK, so you've heard the talk. Now let's see some of this in action. So, got a sort of test organization here. And as you'll see, it's there's about 10 accounts that are used for different purposes. And in this test organization, we've got a separate backup, a centralized backup account. We also have various workload accounts. So if I log into one of the workload accounts, here we are. And you'll see I'm using the new AWS color feature, red for production. Who else here has used the color feature so far? I think it's one of the best releases that AWS has ever done. Thank you, AWS, for that. So anyway, within this account, we have some S3 buckets which we wish to safeguard through a backup process, and we also have a DynamoDB database table, which again we want to regularly back up. So that's what we want to back up. So we deployed the central infrastructure of the central account. So I'll show you that shortly. So at the moment, bearing in mind that I'm in the workload account, let's have a look at AWS Backup in the workload account. So if we go into vaults, you'll see that there are 2 vaults which have been deployed as part of the centralized solution, and that's actually using CloudFormation stack sets. So these are deployed into the workload account by our module, which is great. And as well as the vaults, we've got various backup plans. And the backup plans, as Kurtis described, are actually pushed out from the central backup module as backup policies. The backup policy is set at the organization level. That then translates to backup plans in each workload account. You can see here we've got daily, monthly, and weekly backups. And we're chosen the option to not back up everything. We could if we wanted, but to back up those resources where we've got a specific tag. We're also doing some clever, well, I say clever, this is Kurtis did this bit. So some clever assignment of the right type of backup depending on what AWS service it is. So that's sort of what we've got in the account. Let's just have another look at this. You'll also see that there's vaults shared through RAM. This is AWS Resource Access Manager, shared back into this account from the central account. And if we wanted to do a restore, we could just select this, one of the backups, in this case a backup recovery point from an S3 bucket, and we could do a restore. We can leave the default settings, choose an IAM role, and this IAM role is actually one that is deployed as part of the centralized solution. So that's now restoring, should be finished in about 10 minutes. There's not much data in this bucket. So let's move into the central account now, the central backup account. And what you'll see here is we have our backup vaults. And if we go into the backup vaults, you'll see that we've got vaults which are actually locked and in compliance mode. Now, we don't have to do this. We've chosen to do it. But as Kurtis said, when it's locked, that means that nobody can change it. Even if an attacker has admin privileges on the whole org, they can't change it, which is great. And even AWS can't until that expires. So that's great. And we also have within the central account a CloudFormation stack set that deploys the infrastructure needed to each workload account. And we could choose that to be on the basis of organization unit, so we don't have to deploy it across the whole org. OK, so let's just go back now to the PowerPoint, and we'll start to wrap up. So what we've done here is we've developed a centralized AWS backup solution, made it available to all of you as a public Terraform module. That centralized solution implements the vaults needed centrally, and it also deploys, via CloudFormation stack sets, the resources needed to each workload account. Some of our next steps that we're thinking of is automated restore testing. So you'll see that I did a manual restore. Wouldn't it be great if that just happened regularly every 3 months through automation? And finally, backup auditing. Backup auditing would be nice as a way that we can show to our auditors and accreditors that we're backing up the resources that are important to our business and regularly testing restore. Do you have anything to add, Kurtis?
Thank you, Paul. Just to add that bottom line at the bottom line there, collaborators are wanted. We've open sourced this because we found AWS Backup quite a sharp edge to get started with. And by the show of hands at the start, a lot of people are using it, and you probably found nuances yourselves. So please do come and talk to us about anything you found with AWS Backup that would improve our module.
OK, so with that, we're going to finish. If you want to get in touch with either of us, we're both around for the rest of the conference, and we're also on Cloud Security Forum Slack. There's a QR code for feedback. Do fill that in. And with that, thank you very much.
Thank you. We have had quite a few questions on Slack, so I'm just going to pick one from the thread, and then we'll open it up to the floor here in the room. So a question from Slack. Have backup restoration playbooks been developed and tested? What complexity or extra steps does AWS Backup add to service-specific backups?
So we've tested a restores path. We decided very early on that our restores would only get the backup available in the workload account it needs to be restored to, and then it depends on the underlying service to back up from that. We have tested that, and it does work, but it still requires your service teams to work out how to restore a backup into their own service, and then, say, fit a database or replace the database they're currently using.
Thank you. Any questions in the room? We have a hand, and we have a running mic coming to you.
Any difficult questions, Kurtis is going to answer.
Related to that question, and I hope I'm not getting thrown glass bottles at me, where do you see the benefit of doing automated restore testing, given that it's managed service, and what should go wrong?
Well, maybe I'll answer that one, having said, as I mentioned it. So that's not so much about, we're not really concerned that the AWS backup restore process will fail. But as Kurtis alluded to, let's suppose, for example, it might be a database, and you can't restore to the same database. You have to create a new database. Then you might have to change DNS. So it's really more about the tests for how the application restores that backup than testing the underlying backup functionality.
Hi, Max here. One question regarding the secondary account, the backup account. We also decided to do a tertiary zone. So instead of backing up everything in EU Central 1, we also have a backup in EU West 1 in order to be even safer than this. Are you open to contribution on the module in order to enable this as well?
Absolutely. So far, it works in a single region, but has been enabled to deploy to multi-regions. We've just not added the feature yet, as we're wondering how best to do multi-region. Is it every region should back up single region, or do you want cross-region connections? Another thing people can comment on.
Yeah, it'd be great to have a conversation about this later. So.
Any last questions in the room? Otherwise, we have a bunch on Slack. Okay, let's pick one more from Slack before the break. So we have a question here that says, for compliance lock, you said even with admin permissions, you cannot change it. But what if you have org root access?
You still can't change it. It works the same way as S3 object lock, where even a ticket with AWS support cannot change it.
That's it. Clear as a bell. Now we know how that works. Let's give a last round of applause, everybody.